use either free body diagram 1 or 3, right? Because if I don't use free body 1 or 3, I'm never going to find P. So which, Sarah?
We didn't enforce that.
4 steps? How many steps did other people? Some
Three.
did 3? 3? Aaron, how many fingers did you have up?
I had a hand up, like 2, I think.
2?
I didn't quite get
Okay,
it
well,
all the way,
I'm going to
but
sit down. So let's see if we can do 2 or 3.
1.
Okay, so if we look at P, did anybody have a suggestion on whether doing free body diagram 1 or 3?
1.
Okay, why don't you want to do 3?
I like 3.
Too many unknowns. And the main answer really is because we don't know if block A and B are going to move relative to each other. So the F equals mu n equation does not work between A and B. F is equal to mu n only works when there's about to be pending motion. And we know there's about to be pending motion between B and the floor. But between A and B, we don't know. And if you do the math, the complete math for this problem, which I can make a copy or scan it or something, you'll find out that A and B are not moving relative to each other. Okay, so everybody said they liked 1 first. So let's look at 1. In order to find P, what would we need to find?
NB.
No.
Okay, so you're going long, right? So in order to find P, I would have to do some of the forces in the X, and then I would need FSB, right? And in order to find FSB, I would need mu n, so then I need NB. Can I find NB from the free body diagram 1?
Yeah.
Yes. Okay, so free body did you like the table? I don't know if you like tables or not. I like tables. Equation, solution. So free body diagram 1, we said?
Yeah.
The equation is sum of the forces in the y equals WA negative minus WB plus NB plus, what is it, 500 times the cosine of
60.
60 equals 0. And and NB turns out to be what? Did anybody get the number?
5750. Yeah,
5750.
Yeah,
5750 newtons. Okay, then what do you want to do? Then the friction equation?
Yeah.
Okay, so FB is equal to mu SB times NB, which, what is it, 0.2? 0.2. NB and FB turns out to be 1150 newtons. That wasn't really a free body diagram. You don't really need it, right? It's just a neat. Okay, then, so now we have, can we do P now?
Yeah.
Okay, so free body diagram 1 again. So sum of the forces in the X equal P minus FB minus 500, what is it, cosine 30
Yeah.
equals 0, and P turns out to be 1583 newtons. So Daniel, come on around still. What does that mean? If P is 1,583 newtons, what is physically happening?
At that force, it's not moving.
Right, it's not moving, it's staying
It's the
still.
maximum, right?
Right,
So
Yeah.
it's the maximum that it, before it starts moving?
yes, it would be the maximum for equilibrium. Then, if P Eugene, if P was greater, if P is greater than 1583 newtons, what happens? Lock B what?
It's gonna move.
Moves to the right. Terrellyn and then Santiago?
I'm not sure if friction B is 2,150, I think it's 2,000. No, I think it's 1,200.
Okay, well, somebody else check my math then?
I got
No.
1583.
What?
I got 1583.
So somebody got 1583?
So. Yeah.
Okay, did anybody get to the 1150? Did you get 1150?
I got 1,500.
Okay, so Terrellyn, just check your math, okay?
No, I'm talking about friction B.
Right, I know, but if 1583 is correct, then the 1150 is correct.
What do you have for the normal B?
She's solving for friction.
Oh, I see. Well, no.
You got it, Terrellyn?
Yeah.
Okay. Okay, so if we wanted to find out, okay, Santiago, sorry.
How do we know that P is the maximum in this case?
Yeah, so I don't like the word maximum minimum because it's a little bit confusing. So let's think about what they mean. We're in statics class, so they want to know the min and max for statics, right? Not for movement, for static. So if 1583, if we calculated 1583, it's in static equilibrium. So that means that if it's greater than 1583, it's moving. So that's got to be a max.
So in order to calculate the minimum, will we try to go?
There's no minimum because there's no other motion, possible motion for B. I mean, unless there was glue between A and B, which means, I mean, huge. Right? If A and B were glued and P was nothing and the 500 was pulling it, you would get B to move if it's a really slippery surface. But there is no maximum and min in this problem because there isn't possible motion in two different directions.
So
Okay?
then max and min is more for like when you're on an incline.
Yeah, because that's when you possibly have two motions. I can't think of another reason right now. Maybe in a pulley system, if you add more weight to one side, then it could slide the other way.
When were we given the coefficient? Was it in the problem? I didn't see it.
Oh, it was good. I didn't write it down though.
We didn't need, we're given.
Minus
two.
0.5.
Yeah, minus 0.5. So did you see that under my given, I should have wrote what mu was? Okay, Lonnie, you had your hand up? No? Okay. So if we wanted to go on and find out whether A and B are going to move, I think this is really good. We have a few minutes left. What would I do next? Which free body diagram would I go to next? So you agree that if we don't know if there's movement is going to occur, we can't use the friction equation. We have to use other equations. So what equation would you want to use next? And which free body diagram?
Free body diagram.
Okay, free body diagram 2. Okay, and what would you solve? What would you do?
Solve for MAP.
Okay, so this is, we're going underneath this now. We got the answer. Okay, so we're going to use free body diagram 2, and we're going to do sum of the what? Sum of the forces in X. You can't use the friction equation. So sum of the forces in the X are Fs AB minus 500 times the cosine is at 30 equals 0. And what does FSAB equal? I'm pretty sure I have it.
433.
Yeah, 433.
Is it 433?
I'm going to just lift this. We don't need two of these. 433 newtons. And then what would we use to find out? We want to find the normal. So again, free body diagram, and now do forces in the Y. So this is NAB minus the weight of A plus 500 times cosine of 60 equals 0. And the normal of AB equals 1750. This is actually a really neat add-on problem to find out if they actually move relative to each other. So now let's do the friction equation AB is equal to mu between A and B times the normal between A and B, and we'll put a question mark. So what is mu between A and B? I think it said it was 0.3, right? 0.3 times 1750, what's that equal to? 0.3 times 750?
5.25.
5 point, what?
5.25.
I'm sorry, say it again, Dave.
5.25.
525?
Yeah.
Oh.
Okay.
Oh. Whoops. Yeah.
And then FSAB, we got 433. So what is this telling you? They don't move. A stays on B. Now maybe if the 500 was greater, then they would go relative to each other. So did you see what I did? Let's go back. The question asks us for calculating what P is. And we realized that the impending motion is between block B and the surface. So we can use the friction equation between block B and the surface, which we did. But because it doesn't tell us whether there's impending motion between A and B, we can't use the friction equation, but we can still use our other statics equations. Some of the forces in the X and some of the forces in the Y. And then check if you find out that indeed you can't use the friction equation because they're not moving relative to each other. Jose?
Wait, so if P were to go greater than 1,583,
Okay, if P was greater,
so would then that mean that A and B was, so the rope that is holding A is gonna like snap, and so A is gonna move with B or something?
yeah, so I would say that maybe another part of the question is it possible, what value of P makes it possible for A and B to separate? Because if P is greater, was the 500 wasn't a rope, was it? Was it a rope? Let's look back. I think it was just an external load. It is a rope, but it's an external load of 500. So if P was greater and the 500 were greater, then it's quite possible that A and B would separate. Maybe they might say, find the value of P so that the equilibrium, the surfaces between A and B, maybe they could say, find the value of P that'll get B to slide under A. And then we could go about doing that. And then we know the friction equation would hold. Uriah and then Lonnie?
If they had equaled each other, then if they slide, or is it if one's
What equals each other?
if we found the static friction between A and B?
If those two values equaled each other, then you know that A and B are moving relative to each other.
But only if they're equal to each
Only if those two values are equal, correct? Lonnie?
To get A and B to move separate from each other, wouldn't it be just like a diagram of just A, and the components pulling A, that force would have to be larger than the force of friction on the bottom, right? So you'd need either a larger force or a smaller friction to make
So if we look at A, we would need this X component, right? It's not the 500 that's greater, it's the X component of this 500 needs to be the value of this.
Less than the two. So wouldn't we need to like,
You could,
be a different
I mean-
coefficient of friction to make them move, right?
right,
At this rate, at those ones, the friction's just plain gonna be stronger, it's just plain gonna move it along.
so what you're really saying in the end is that we're looking at the possibility of three things causing A and B to slide relative to each other. And they're all along the x-axis. So if P was greater, or the 500 was greater, or the friction between the two was smaller.
Actually, I'm saying that
Oh.
it doesn't matter, if P's enough to move B, that doesn't matter once we go to whether the two go apart, because now we just look at A, and it's just between the friction
And the
and
500.
and the component of the 500, it's
Ah,
just
yes.
those two, right?
Okay, so what
They're not gonna
Lonnie,
move.
yeah, so Lonnie's saying that P does not impact whether A and B moves or not. It's really the 500. But no, but the P we calculated is only based on static equilibrium, so if P is greater, it's gonna pull. It's
That's
gonna
what I mean.
overcome the friction.
But yeah, but the P is up, once we're just talking about between the two, we don't, the P becomes part of that friction. And now it's just, is the friction enough to pull it against the
Okay, so the value of the frictional force AB between the two blocks is relative to P, correct?
Yes.
And as long as we know what P is, we can find that, and then the 500 needs to overcome.
It's not, because it's just, the friction is just the normal versus the coefficient of friction. So at that point, we just have, you could put, it doesn't really matter, it's just the normal versus the coefficient of friction, right? Pulling to the right versus the X component of the 500 pulling to
So
the
you're
right.
saying, if we use the equilibrium, if
Not
we use
that
the
one,
friction of, I know, but if we use the friction equation, this is equal to mu n. This is equal to mu n. So then these two are taken care of regardless of what P is. Yeah, you're right. Well, then we're talking about there being some of the forces equal mass times acceleration, because then we're moving. But I'd like to do the number crunching and see if P matters. Let me go on to the next question.
I'm kind of just trying to go off what she was saying.
Okay, we're actually over time, so
Okay,
let me let.
I can go after.
Okay, so Tuesday is